Hello, I'm Hein, and I will start this week's review. Uh, Today, I have two concepts to talk about. The first concept is the MOSFET capacitance, and second topic is the basic concept of the CMOS. First of all, uh, we had talked about the MOSFET capacitance before in the maybe second reviews or third reviews. Mm, at the time, we saw the very simple figure of the MOSFET capacitance. Now, I will explain the basic principle of the MOSFET capacitance. Uh, First of all, we can see that this picture. Uh, in this element, we can see the gate and the capacitance between gate and channel. If we apply a high voltage in the gate and low voltage in the channel, in the strong inversion area, we can see only the COX, the oxide capacitance. But if we lower the gate bias, the MOSFET becomes the depletion state, and in depletion state, uh, like this, in the pop line, between the body and the source and drain, we can see the junction capacitance. So if we add the junction capacitance in the oxide capacitance, the total capacitance become low than strong inversion region. So we can draw this kind of graph. This kind of graph. And in second situation, we will see the capacitance between gate and body. If we apply high bias in the MOSFET and low bias in the body, in accumulation regions, we can see only the oxide capacitance in this element. But if we increase the gate bias, so in depletion region, we can see the depletion capacitance like this. So if we add the depletion capacitance in the oxide capacitance, the total capacitance become lower than the accumulation situation. So if we combine these two type of graph, we can see this graph. This is the graph I saw you before. Like this, we can explain the total capacitance of MOSFET in this process. And we have know about the MOSFET. The current before the threshold voltage is also important. We call it as a sub-threshold swing. The detailed meaning of this is the current slope in the under threshold area. It is easy to say the slope in the sub-threshold area is very small because we can see the increase of the current. But if we change the scale of the graph in the IV curve of MOSFET, like the voltage is in normal scale and the current in log scale, we can see the current increases very dramatically, like exponential graph. So we have to know the threshold, the subthreshold swing cannot be big than the cannot be less than the 60 millivolts per decade. And the second topic I'm gonna review is the basic concept of CMOS. As we saw before, if we apply the bias in the MOSFET, we can use it as an inverter. Like this, if we bias the lower voltage like 0 in the gate bias, the MOSFET acts like an opened loop. So the output voltage become equal to the VDD. And if we apply the gate bias as a high voltage like VDD, the MOSFET becomes the shorted loop, so the V output becomes the 0 voltage because it links directly to the ground. It means we can use the MOSFET as a common source transistor. But if we use the single transistor as an inverter, there is a problem. Because the current flows directly in the MOSFET, so it consumes a lot of power. So we can use the other kind of elements, which is called CMOS. The CMOS is the very simple element. If we connect the two kinds of MOSFET, like P-type MOSFET and N-type MOSFET, we can call it as a CMOS. Like this. In this situation, the current couldn't flow in direct way, so we can save the current. This is the very simple principle of CMOS and the reason why we use the CMOS. I'll finish today's review, and next week we will talk about the short channel effect. Thank you.